Okay, hello everyone. Now we are going to solve example 2.3, which is named as type 1 problem. Of course, while you are solving the problems, those names type 1, type 2, or type 3 will not be given to you. You will understand which procedure that you need to follow. Now for this problem, we had been given a galvanized iron pipe with a roughness height of 5 times 10 to the minus 3 millimeters. With a diameter of 5 centimeters, the length is given as 100 meters, and the discharge to be carried is 3 liters per second. And we are asked to calculate the head loss. Also, the kinematic viscosity is provided because it is in square meters per second, as we know. Now, we had listed the givens of the problem. Please be careful to the units, as we had always talk about. The discharge here is given in liters per second. What we did is we converted it to cubic meters per second. Diameter of 5 centimeters is converted to 0.05 meters. Length is already in meter. Kinematic viscosity is written. Epsilon here is given in millimeters, but I think it's a good idea to make the conversion to meters also. Okay, now it asks to calculate the head loss. So how do we find the head loss? We know that we use for head loss, we know that it is composed of two terms, friction and minor losses. As this is a single pipeline without any fitting, there won't be any minor loss. We will discuss that minor loss calculation in detail in coming courses. Now, this head loss is just due to the friction loss that we have. So we know that we will be using Darcy-Weisbach equation to calculate the friction loss. So for that friction loss for Darcy-Weisbach, we know that we are in need of a friction factor, F. And that friction factor is function of two terms, Reynolds number and epsilon over D ratio. So I need to calculate that Reynolds at the very beginning. So to calculate the Reynolds number, we have to calculate the velocity of flow. Velocity is simply Q over A. Q is 0.003 cubic meters per second. Area is pi d squared divided by 4. Diameter needs to be in meters. If you make this calculation, you can find that the velocity is equal to 1.528 meters per second. Knowing this velocity, I can calculate the state of flow by calculating Reynolds number. Reynolds is nothing but average velocity times the diameter divided by the kinematic viscosity. So if you just substitute every term in, velocity is 1.528, diameter is 0.05, and kinematic viscosity is 10 to the minus 6. If you make this calculation, you see that Reynolds number equals to 76,400, which is much larger than 4,000. Hence, I can name it as turbulent flow. So we know that the state of flow is turbulent. If you were to have a Reynolds number less than 2000, we know that our F will be equal to 64 divided by Reynolds. At this point, as we have turbulent flow, I need to solve for that F either by making use of Moody's chart or by using Suomi-Jain equation. But other than the Reynolds number, we need to calculate the relative roughness term. Relative roughness is simply epsilon, roughness height of the pipe, divided by diameter. Be careful, they need to have the same unit. So I expressed that epsilon in terms of meters also. Diameter is already converted to meters. So my non-dimensional epsilon over D ratio is calculated. So as F is function of Reynolds and relative roughness, we put everything into the Suomi-Jain equation to solve for our F value. So this equation, it's not easy to use, so please get used to Suomi-Jain equation. Do calculate this equation by yourself also and try to find that 0.0194. Be careful for this F. We always try to write the F in 4 decimal digits. So you need to have that 4 units after the dot. So for HF calculation, Darcy-Weisbach, using Darcy-Weisbach equation, just substitute each term F, L over D, V squared divided by 2G. We obtained that it is equal to 4.617 meters. Now, this is the thing that is asked in the question, friction loss or head loss. Now, the same question might ask the calculation of pressure drop, for example. So all you need to do is to write the energy equation between two sections, 1 and 2. The elevation heads might be provided, or you can be given that the pipe is horizontal, hence Z1 will be equal to Z2 in that case. So all you need to do is to solve for P1 minus P2 from the energy equation, and of course using the known value for friction loss at that point. This is one thing. Another thing, in the problem, you can be given the information that the flow is smooth. You have hydraulically smooth flow. Then all you need to do is this term, epsilon over d term, will be equal to 0. It doesn't matter if the pipe is concrete, plastic, or glass. Every material, of course, has its own epsilon value. But if in the statement you had been given that the pipe is smooth wall, or you have hydraulically smooth flow in the pipeline, all you have to do is to take this epsilon over d ratio to be equal to 0. So your F will be just a function of Reynolds number. On the other hand, if you had been given that you have hydraulically rough flow, then we know that this term will go to 0. How? Reynolds number will go to, we will assume that the Reynolds goes to infinity. So that's the region where you have horizontal epsilon over d lines for any Reynolds that you enter. So for fully turbulent zone. So please read the questions well. So depending on whether you have smooth, transition, or hydraulically rough, you can all adopt these friction factor calculation by making use of Swami-Jain equation. I hope it is clear.